So our today's topic is enthalpy of interconversion. Enthalpy of interconversion state of matter. So what does this mean? This means that when we heat up the state of matter, it will be transformed into another. Mean here heat contact of the body and it will transform into another matter. So let's have a look. First of all, we're gonna see we have enthalpy. We're gonna make enthalpy figure and then you're gonna understand that. So first of all, we have common matter and non-common matter. Common matter are usually found on earth, that is solid, then liquid, and then gas. More than gas, we have non-matter, that is plasma and BES, Bose-Einstein condensed state. So when we convert from the process of solid to liquid is known as melting, or you can say fusion. Then from the process of liquid to gas is known as boiling. You must say evaporation, but let me tell you that boiling occurs at a very heated temperature. Boiling requires heat, more heat. And evaporation, talking about the evaporation, so evaporation can be occurred at every temperature. It is occurred at every temperature, but boiling occurred at only high temperature. So the appropriate word for this process would be boiling. Then we goes from gas to plasma, and that plasma is known as process known as ionization. So let me tell you that plasma is not found on earth. This found on a very high temperature, and that can be sun. We know that sun is the hottest planet, so plasma can be found at sun. And talking about Bose-Einstein condensed state, it is a state of matter. These all five are state of matter. These two are being new in this course. So Bose-Einstein condensed state of matter is can be found at a very, very low temperature. At the lowest temperature, and the limit of that lowest temperature would be minus 273.15 degrees Celsius, or at 0 Kelvin, means zero, absolute zero. So this is found at a very, very high temperature, and the range would be 3000 Celsius to 5000 Celsius. And talking about Bose-Einstein condensed state, so it is found in lowest, means the chilledest place at this temperature. So now we'll have a look at ionization. Then what is this ionization? Ionization means, first of all, it will occur in the neutral body. We'll have a look. First of all, let's have an example that we have hydrogen. So this hydrogen have 2 proton and 2 electron, because the number of proton and the number of electron is quite same in every element. So this is an hydrogen element. So if ionization will occur at hydrogen, so the first of all we'll give the temperature, and the temperature would be very high, very high. So the forces between these proton and electron is known as electrostatic force would be breakdown, and they will be converted into 2 proton and 2 electron. When they will be broken down into this, means they have ionization state at a very high temperature. Temperature must be very high. Now here we have another example, that is NaCl. If we give it a very temperature, that is 901 degrees Celsius, for example, if we give, so here electrostatic bond will be break, but here the bond will be ionic bond, because here we have given the weak temperature. So here the bonding between Na and Cl is ionic. They are an ionic compound. Due to we have given the lowest temperature, here ionization is occurring, but here the ionic bond is break. So let's see now, if we ionize, if we give the temperature 901 to NaCl, so what will happen? It will convert it into anion and cation. This is anion and that is cation. Here ionization is occurring, but at a very low temperature. So when you give the low temperature, they will convert into anion and cation. This is the difference between a chemical compound and an element, and the main difference comes with the only temperature. Here we are giving the temperature maximum 5000 degrees Celsius, and here you can see it is quite low. So that is why here it is converted into anion and cation, but here it is converted into 2 proton and 2 electron. Got it? Now we will move reverse, in a reverse direction, and that is fun. So here we have plasma. We have plasma. Plasma to gas is known as what? Plasma to gas is known as deionization. Gas to plasma was known as ionization, and plasma to gas was known as deionization. Gas to liquid is known as what? It is known as condensation. And liquid to solid is known as what? It is known as sublimation. These are processes. And then again, solid to gas. Solid to gas. Solid to gas. Solid to gas is known as what? Liquid to solid is known as freezing. And solid to gas is known as sublimation. then again those gas particles will combine with each other, and they, for example, this is a gas particle, okay, after sublimation. This is, they will combine, they will merge with each other, and they will in the form of this. So that gas particle to solid is known as decomposition. What? Decomposite. Okay, I hope deposition, because gas particles are being deposited, so that is known as deposition. I hope that is clear. Let me just repeat again. From solid to liquid we have melting. From liquid to gas we have boiling, not evaporation, because evaporation occurs at every point. On the other hand, boiling occurred at a very high temperature. From gas to plasma we have ionization, and we have another process for Bose-Einstein's condensed state of matter. We'll discuss that. Then we are coming in reverse direction, so we have plasma to gas, that is deionization. From gas to plasma was ionization. Now plasma to gas is deionization. Gas to liquid is condensation. Then liquid to solid is freezing. This is a very quite ice. When you keep ice out of your fridge, so it will convert it, means the solid, means the liquid will convert it into solid, that will call melting. But here when you keep the water into fridge, and it will convert it into ice, so that is freezing. Now again solid to gas is sublimation, means the ice is now solid, but here the gas particle of ice are coming out, so that is known as sublimation, means ice is converted into gas, that is known as sublimation. Then again this gas is converted into solid, and that is known as deposition. As I told you that here are the gas molecules, when they coincide with each other they become so in a very less area, so here the gas is deposited. So that process is known as deposition. Now we're gonna discuss about the forms, how we can write the forms. So our first form is gaseous form, that is known as storing form as well. Let's see how. So now, for example, we have NaCl. When we heat NaCl, so the bond will be break. For example, yes, exactly, the bond will be break. Na will get separated and Cl will get separated from these together. They will get separated. So Na will contain the gaseous ions. When the bond will break, Na will get gaseous ion and Cl will also get gaseous ion. Okay, so how can we write this? Nag plus Clg. This is known as the gaseous. Okay, let me tell you that for example, we have water. Okay, OH is the negative part of our water and H is the positive part of water. So we have Na plus. So where it will go? It will attract to this, because gaseous ion will negative and positive will attract to this. So this is known as hydrated. That water will be known as hydrated. Okay. Then same comes with when we'll add NaCl to water. So the water then after putting into water, Na will get the positive sign and it will represent as AQ, that means aqueous, plus Cl will be negative and that will be AQ, aqueous. Now talking about in NaCl in solvent, so Na will be in the positive because it is an anion, and we'll write SOL, plus Cl will be negative and we write. So this is how we write, and this is the proof. This is how we write, and this might comes in MCQ, but the main purpose was telling you what is gaseous form. It means storing of ions. As we see that when we give heat to NaCl, so Na will get the gaseous ion and Cl will get the gaseous ion. When we'll break it by water, so Na will get the aqueous ion, and same as here with Cl. When we did with NaCl, we did into solvent, so Na will get the solvented ions.